Okay, in this video I'm going to show you how you can implement the one segment shifted geometric model. So as we can see over here, we've got data in each month, and for each month we've got the number of customers that are still alive in that month. So this is assuming that we started with 1,000 customers. When customers are born, they must be alive, and then in all future months some number of customers is going to churn out. And the question is, how well can we model this data? So imagine that we only got to observe the first 7 months of data, and we wanted to predict data in months 8 through 12. The way that we can run our one segment shifted geometric model is in this tab over here. So what I'm going to do is I'm going to first grab this data that represents the number of customers who are alive in the first 7 months. I'm then going to convert that into the proportion of the cohort that is alive in each of those months, as we see over here. And then I'm going to get the model-based expectation for the proportion of the cohort that's alive. So imagine that theta is 0.5. In the first month, we would expect 50% of the customers to churn out. And so 50% of the customers are going to remain. And then month 2, we would expect 25% of the customers to still be alive, and so on and so forth in all the subsequent months. And the way that we're going to estimate theta is we're going to find the value of theta that minimizes the difference, the sum of the squared difference between expected and actual retention curves, or the expected and actual percent of the cohort that's alive. So I'm going to basically take the difference between this number and this number, square it, and then I'm going to go up over here and sum all those values. And then I'm just going to find the value of theta, again, that makes this discrepancy as small as possible. So obviously, intuitively, if theta were 0, no one would churn. We would expect everyone to be alive. If theta were 1, we would expect everyone to churn immediately. And so the truth is going to be somewhere in the middle. The way that we're going to find the exact value of theta is to use solver over here. So I am going to minimize the sum of the squared error by changing theta. And the only constraint that I'm going to have is that theta needs to be less than 1, and it needs to be greater than 0. Those are the two constraints. Solver. Here we go. So we can see we estimate a theta of 0.112. Now let's see how well we did. So let's kind of take that data from our holdout period. Let's get the proportion of the cohort that was alive in those months. Let's get what we would expect the proportion of the cohort that's alive to be. And then let's just compare expected versus actual. We can see the chart over here. Blue is actual, orange is expected, and we can see if we were to add, I can just kind of leave this as is. We see that after month 7, we're systematically underpredicting. So I'm just going to put this over here. Expected versus actual retention curve, one segment model. And yeah, I could prettify this chart, but we don't need to go any further than this. So hopefully this whole process makes sense. This allows you to be able to implement the one segment model.